An analog cathode ray oscilloscope, or a CRO, is an electronic test instrument used primarily for displaying and analyzing the waveform of electrical signals. It operates based on the cathode ray tube (CRT) technology and is a fundamental tool in electronics laboratories. The front panel of a typical analog CRO is as shown, with a brief function of each button. Let us look briefly at the function of these controls. 1. The intensity knob helps in adjusting the brightness of the trace. 2. The focus knob helps to adjust the sharpness of the trace. 3. The position control helps in adjusting the position of the trace on the screen. 4. The input coupling selects the type of coupling, AC, DC or ground, for the input signal. 5. The channel ground sets the channel ground level. 6. The time base or sweep time controls the time scale on the x-axis. 7. The volts per division or amplitude knob controls the voltage scale on the y-axis. Use the CRO to measure amplitude and frequency of a waveform and learn its operation. Listen carefully to instructions and perform the activities. Ensure all push buttons are in release position. Set level and hold off knobs at center and variable knob locked at cal, that is, in calibration position, verified by the LED being off. Set time base to 0.5 milliseconds per division and volts per division to 0.5. Power on the CRO. Press CH1 to display only one channel. Ground channel 1 using its ground button. Adjust the trace of channel 1 with Y position knob to align at screen center. This establishes channel 1's ground level. Adjust intensity and focus knobs for a bright, sharp trace aligned to ground level. Now, using the CRO probes, feed the test signal available from the test point TP to channel 1, that is CH1, ensuring that the red or signal wire of the channel is connected to the test point. The black wire or ground connection or reference can be left open since reference is internal. Interpret reading the peak-to-peak voltage and frequency of the waveform. The peak-to-peak voltage value is obtained by counting the number of divisions spanned by the waveform along the vertical and multiply the count by the volts per division factor. The frequency of the waveform can be similarly obtained by counting the number of divisions spanned by the waveform along the horizontal and multiplying the count by the time base factor, that is time per division.